So, so I'm going to do a deep dive on a particular project with Marina Dubova, which is who is here present in this room, and I'd like to look at some particular ways in which labeling, one particular very specific aspect of language, can influence our perceptual encodings, building on what Gary just was talking about before. And so I'm admittedly taking a very minimalist approach to language's influence in the same way that social psychologists have these manipulations, which are minimal group manipulations, where they just put people into groups saying, you like Kandinsky paintings and you like clay paintings like Paul Tajfel used to do. So we're not taking on language in its full complexity at all. And so the particular kind of paradigm that we're looking at is one where there's two different tasks that are going to be interleaved with each other. One is labeling with instantaneous feedback from the computer about whether the label provided by the subject is right or not. And the other task is a reconstruction task. And so I should probably, maybe I'll send you a link to the experiment later on if you want to try it out yourself. During the labeling trials, you get the trial by trial feedback, and then 20% of the trials, subjects are going to then get a reconstruction task where they see a fish on the right side, and they have to exactly try to reconstruct that fish in the left-hand side, as you can see there. And they just move their mouse around in order to try to change the appearance of that reconstruction fish. The fish are organized in a 4x4 grid of fish, and there's two different types of labeling. In one type of labeling, the left fish are the P fish and the right fish are the Q fish. In another kind of labeling, the lower fish are the Q fish and the upper fish are the P fish. And so that's how we're keeping constant the experience that subjects have with the images, and yet we're changing the influence of labels. Here, not labels endemic in the language community, but language labels that we're just giving in the experiment itself. Okay, and the reconstruction paradigm offers a couple of interesting advantages from our perspective. First off, when you're reconstructing the fish, it's right there in front of you. So you might think that this is going to heavily reduce the memory influences to say that it is actually your perceptual encoding which is changing rather than just what you're remembering. And because the reconstruction is in the same domain as the image, we can argue that we're reducing the influences of certain judgmental or scaling influences. So it's one thing to say that if you give people a task where they have to give a Likert scale on how red is this particular object, there could be all kinds of nonlinear scaling influences going from your sensory experience to your label. But we don't have any of that, in that the reconstructed fish is in the same currency as what you're seeing in front of you. Okay, so those are two things that we're doing to make it a stronger case that what we're really talking about is a perceptual encoding influence. And there, the final caveat is, yeah, this is very short-term labeling, not dealing with any of the real nuances of language as all of you are talking about. So there's different accounts for what the influence of this labeling could be. I'm going to give a quick gloss on these and probably just dive directly into the results. But there's classic kinds of accounts of perceptual warping, whereby the underlying sensory dimension, which is relevant for the labeling, becomes either emphasized, or there's versions of perceptual warping where the differences that don't make a difference, that don't take you out of a category, become underemphasized, as in Livingston et al.'s work. There's a line of work from Bayesian perception which would say that your warping is going to really be best understood as regression to the category prototypes. And there's also a recent theory called rate distortion theory, which would say that you're going to devote more of your informational bits to the relevant rather than the irrelevant dimensions. So those are some of the kinds of theories that we're interested in looking at. So the particular kinds of results that we get, we can see where the original stimulus was, and then we can see where a subject's reconstruction of the stimuli ends up. Where the original stimulus is shown by the dots, and where they end up is shown by the triangle positions. And so you can see there are some regular distortions. One kind of regular distortion is movement towards the global mean of all of the stimuli. And that's sort of shown by this overall shrinkage. But you can also see that there are some differences due to the category labels, either the horizontal category labels or the vertical category labels. And just to highlight one of these is that you can see that there's more migration towards what would be the horizontal boundary, which is confusing because it actually shows up as a vertical line is the boundary that you get when the horizontal dimension is relevant. And you can see that there's more migration towards that horizontal midline when you have the vertical categorization rule than when you have the horizontal categorization rule. And so that is consistent with this idea that the people in the horizontal categorization condition are trying to avoid that category boundary because it is really a boundary for the horizontal people. So there are much more sophisticated ways of showing the results. This is a whole iso density contour, which is an advantage that you get with this reconstruction method. So here you can see exactly the distribution of distortions that people make. I'm going to send this to everybody in the chat window because it really requires quite a bit of thought and concentration to look into. But some things I think you can get out of the results from a more standard hypothesis testing perspective is like on the left side graph here, the y-axis is the absolute reconstruction deviation. How good are people, basically? And we can see that people are better overall for the vertical dimension than the horizontal dimension. But in this left graph, we're also seeing an interaction with the categorization labeling, so that people are better able to do the horizontal reconstruction when they're in the horizontal labeling condition. And they're better able to do the vertical reconstruction when they're in the vertical label condition. And that is consistent with rate distortion theory. We also find evidence for what would be called categorical perception of an acquired sort, where people show less of a bias towards the category boundary when that boundary is active for them, given their labels. And that shows up most conspicuously in the middle graph because this bias in the horizontal dimension is much less when you actually give people a horizontal categorization rule, as if they're trying to avoid crossing this categorical boundary. We did not find evidence for Bayesian perception to the category prototypes, even though we find Bayesian perception towards the overall means. Okay. So given this very minimal way of understanding language, we do see that labeling does seem to reach down to change the perceptual encodings that people give. Even when we took some methodological pains to try to reduce memory and judgment effects, you can ask, like Firestone and Shull would ask, why we don't seem to find an El Greco fallacy. We can talk about that if you want during the discussion. But the El Greco fallacy would say, hey, just like there's an influence of your labels on the object that you're supposed to be making judgments about, why isn't there also an influence of labels on this reconstructing object, the fish that you're moving around in order to try to show what you think the actual fish is? And my short answer is there's no reason to think that labeling would influence target and the manipulator object, this reconstructed object, equally. So overall, I think you can make a claim for an analog of what Dan Slobin has been talking about for thinking for speaking, and you can make a similar argument for perceiving for speaking, making the adjustment of speaking to communication and thinking of this as a very minimal case of communication by way of labeling the objects. Okay, thanks. And I'm now open for questions.
I have a question, Rob.
Yeah.
If I understood your squares and triangles with the arrows plot correctly, it looked like there was migration. I don't know if you can put that back up. It's a little hard to remember, but it looks like there was migration of the fish towards the category boundary, less so in the vertical case than in the horizontal case. But it looked like, let's see, maybe I can point to it. Yeah, there, I think. Yeah, so on the left there, maybe I'm just misunderstanding, but what causes, which of those theories predicts that a shift in that direction towards the categorical boundary? Shouldn't it be away or towards the center of the category?
Yeah. That's a good point. So categorical perception would be predicting a shift away from the category boundary, right, as you so astutely put it. So what additional theory could predict this general movement towards the boundary is a sort of a regression to the means, a regression to the global mean. And this part of this could also be people giving up on the task, or people if you don't try very hard, you might have errors that would look like you're moving more toward the mean. So that's the strongest influence. And so when we talk about, and that's why it's kind of awkward to talk about, when we talk about categorical perception, what we really have to talk about is an influence of the category labels such that there's less of that assimilation toward the population mean for a situation where the boundary is active. So what I guess we can say is that I think what we say is there is active categorical perception going on, but it's not strong enough to overcome this global assimilation.
I see. Yeah, that makes sense. Did the participants see these grids the way that we see them?
Yes and no. They don't see the category objects. So they get one category object after another, and they don't know that there's this underlying 4x4 organization for those objects to be categorized. And the dimensions themselves are just arbitrarily created by pairing together different species of fish. However, when you go to the reconstruction mode, the reconstruction mode exactly is going to show this two-dimensional organization. And you'll see this when you play around with the links that I just sent out to you. So if a subject were smart, they would take into account the organization that they experience when they're doing the reorganization to contemplate the idea that this might be how the objects themselves are organized or for categorization. And I don't think that many of the subjects are actually making that connection.
Got it.
But they could.
Yeah. So you think, well, I don't want to take too much time if someone else has a question, if otherwise.
I have a brief question. So how do you think, or whether this relates, there's all this monkey work showing that when you teach monkeys similarly, just with rewards, the same category boundaries, you get really strong effects in the cortical representations, and that's definitely not language, right? That's just sort of differential reward or reinforcement learning. And so I wonder how that speaks to, this work saying something about language, or something just about categorization.
Yeah, so that's a great question. So, I mean, like Gary and I's worldviews are really, really very similar to each other. And but the one point where I might have had a different view is when he was introducing this entire workshop. He talked about like the cognitive science tradition being to learn from experience rather than learning from language. And to me, it's hard to distinguish between those because language is part of experience. And my particular gloss of language as being labeling makes it even more closely tied to what standard cognitive psychologists, standard cognitive scientists would think about associations that are present in the world. So the kinds of things that I'm talking about in terms of label and association of these simple labels to things in the world are definitely in keeping with what I think you were alluding to, which is the possibility that the regular old stuff that we associated with association learning could be completely what's accounting for people's changes in their perceptual encodings here.
And we should probably go on just as a brief, very brief response. So I totally agree with everything Rob just said. I would add that it's in the monkey case, it's the experimenters creating this world for them where they're being rewarded for certain kinds of behaviors, right? And language is creating that world for us in some ways that mirror the rest of the world, the perceptual world, but in other ways that does not. So the real world doesn't contain abstract blueness and redness and squares and triangles, right? But language does, the world of language does. And there's nothing inherently special about linguistic labels, they're part of this larger symbolic system that we learn in the course of our normal experience.